to yours because I don't think I can.
Okay. Yeah, no worries. I can
fully unrestrict it.
do
All right.
it.
So recording just started, and today we have a presentation from Damien on SSH signing in Git. So thanks for everybody that noticed the calendar change and stuff. I got pinged by about 3 people during the normal time today asking if the meeting was happening or not. So somehow some people missed that. I'll send out a link to the recording after. You want to get started, Damien?
Sure, let me just go ahead and present.
Sorry, what were you going to say, Kim?
Oh, I was talking to myself. But yeah, I'm filling out the agenda, so if you want, Sonia, throw your name up there. And now I'll go on mute.
Usually smart to mute before you talk to yourself.
Now I just have to find which tab I've got this in. It's a bit of a mess, my Chrome, unfortunately.
Damien, you're a little quiet, so you might have to.
Yeah, sorry. I'm just trying to find the tab that I'm supposed to be presenting, and
okay.
it's hiding from me. I'll just do this. Okay.
Damien, is there a URL where this slide deck will be available? Because I fear that we forget to ask and then they're gone forever.
Oh, sorry, you missed that. I'll make a copy. You just using my personal email. Sometimes it's hard with our Google email addresses. Damien and I will figure it out, and I'll be sure to post them in our notes.
Awesome. Thank you so much. I'm looking forward to this.
Cool. So just by way of introduction, I'm a tech lead manager at Google who's done some work in open source supply chain. I'm also a maintainer of OpenSSH. So I'm very much speaking with the first hat on today. Though the work that I'm talking about does cut across both to some extent. So this is a talk about what I'd like to do with signing in Git, and it's really centered around this vision, which I think is an important one for supply chain attribution, and that's that every object and every line of code in a repository can be attributed back to its author, and ideally from something that can't trivially be stolen, like a hardware root of trust. I think this sets the stage for all sorts of things that come after the source code reaches someone who depends on it, and I think it's a precondition for addressing a lot of the problems in the security supply chain for open source software. Why? At a broad level, cryptographic signatures prevent tampering. There's caveats, of course, around life cycle of keys, etc. But having signatures is generally superior to not having signatures, all things being equal. Being able to attribute code back to developers prevents a developer impersonating another, and pushing changes that purport to be from someone who they're not, without being able to be detected. And that attribution also lets us draw a line around a bad actor's contributions. So when someone turns out to have done something bad, we can identify to the extent of that badness and cut it out, or take remedial action, or do forensics on that. I think also more broadly that when in a world where developers' actions are attributable back to them, it gives them a bit more skin in the game, and raises the cost for a persistent attacker to create an identity that injects malice in somewhere if they know that identity is going to be burned as soon as that malice is discovered. And I think attribution, attribution is a key element to being able to get to that state. I mentioned the hardware roots of trust because that's an element that deters theft of keys, or prevents theft of keys in the ideal case. If a key can be stolen, by a client-side bug on a developer's workstation, then that attribution story falls apart very quickly, and that sort of attack occurs with some regularity. Putting the key into a hardware root of trust means that the attacker can only steal use of the key, and subject to all the caveats of being able to do that. That they've got to be on device with their victim. They've got to be get their actions hidden from the victim, and they're subject to a lot more constraint, and they're generally going to be a lot more detectable than an attacker who can just steal a key, walk away with it, and carry on as they like. Subsequent transforms, and I'm sure this working group has talked about things like in toto and trusted or reproducible builds. They're only as trustworthy as the source code that they take as input. So improving that trustworthiness of the source has ripple on effects all the way down to consumers, and that's why I think getting the trustworthiness of the source code improved is important. So what's missing now? One of the key things is that most developers don't sign their code in a general sense. It's relatively common to sign tags and releases in Git repositories, but not so much to sign every commit, and even rarer to use the push signature feature in Git. Now, I attribute this in some part to the difficulty of use of OpenPGP. It's got there's been multiple papers written about how its trust model is difficult. The series of Why Johnny Can't Encrypt papers by Elmer Witten and co. There's no direct linkage of GPG identities with repository identities. In practice, most repositories build that as a as a feature. So, for example, GitHub lets you register PGP keys, and hardware support within most PGP tools requires PKCS11 tokens, which generally require, in turn, middleware and daemons and additional configuration, as well as being relatively expensive. Another thing that's missing, pardon me, is a wider life cycle story around signatures within Git. So if I, excuse me while I clear my throat. If I take a contribution by rebasing it or rolling it, squashing it into a single commit, and applying it to my tree, then any signatures on the objects that contributed to that commit are lost. So these operations are relatively common and exist for good reasons. Not everything in Git can be a merge, for example, I think practically. So a story around preserving signatures across those mutations is another thing that's missing at the moment. My proposal here is teaching Git about SSH signatures, and basically making it a peer signing method to OpenPGP signatures as they are at the moment. And my rationale is this, that SSH is basically everywhere. If you install a general purpose computing device, you have the OpenSSH in its client tools almost certainly installed, be that on Windows, Mac, certainly Linux, BSD, etc. The trust model for SSH is very simple, and developers are very familiar with it. It's flat. It's comprehensible. There's no friends of friends type explanations that need to happen there. most developers already interact with their Git repositories via SSH. So there's already a trust relationship there. They're already using the tools. They're already familiar with the tools to some extent. And consequently, repository hosts already maintain users' keys at their end, and they already maintain some sort of mapping from those keys to user identities. So it seems to me like all of the pieces of a wider identity story are already in place. We're just missing a couple of linkages to really make it usable as an end-to-end system. And finally, SSH signatures can easily be tied to a hardware root of trust, and I'll talk a bit about some of the work we've done there in a moment. So as far as implementing this vision of making SSH signatures capable, or Git capable of using SSH for signatures, we've taken some steps, and there's some steps left to take at the moment. One of the first steps we took was building a basic signature mode into OpenSSH, which we did last year. This is built in, if you're familiar with the OpenSSH tools, this is built into SSH keygen and allows signing and verification of messages with a very simple trust model that should be familiar to most users of SSH. It's authorized keys like file that maps identities to keys, and it supports namespacing of signatures. So, for example, a signature that was intended for use by Git could exist in a separate namespace for a signature that was, intended for signing a tab or an email. And so they're kind of separate domains within the protocol that frustrate cross protocol attacks where the attacker creates an SSH server that gets the user to sign something that looks like an authentication request, but is actually a Git commit. So that those sort of attacks are frustrated. And this is really designed to be as familiar to SSH users as all the other tools. The keys are just SSH keys. You can stick them in an agent. You can use a certificate. You can stick them in hardware, and they all just work kind of as normal.
What's an identity in this context? I'm only really familiar with using SSH to talk to an IP address or something like that to trust.
Right. In this case, the identity is a UTF-8 username, which is basically unconstrained by the SSH side of tools. So it can be a user at domain, it could be a username, it could be anything basically. This does not prescribe a particular identity model. It's just but it provides the glue by which you could build a system. You could plug it into a system that already has an identity model.
Thanks.
Getting hardware-backed keys ubiquitous is another challenge. Like GPG, OpenSSH has supported PKSys11 tokens for over 10 years, but these tokens are generally comparatively expensive. I think they've come down hugely in price in recent years, but you're still looking at $50 per token, maybe 30 at the low end. And they're more fiddly to set up. You have to install middleware that talks to the cards, or they come out of a model that is smart card based and inherits a lot of baggage from that. I think there's some simplification in progress, but it's not, it's incomplete. So early this year, OpenSSH added support for FIDO/U2F keys, which is you're probably familiar with it, but if not, it's a authentication model that was designed for the web that uses basically splits the key into a hardware resident part and a part that lives either on the outside the key, and combines those at the time of signature to derive the real key. Because they require very little storage on device, they can be much more. They can be much cheaper than PKCS11 keys. I think at the low end, you can pick up a FIDO token for less than $10 US. They're quite simple to use. They have a lightweight specified USB protocol to speak to them that doesn't require complicated support. And they're generally configured to require that the user touch or tap them once per signature operation. And this is a really nice feature to deter theft of use attacks against the user's keys, because the user actually has to physically authorize a signature under most circumstances. So even if an attacker does obtain code execution on their victim's machine, they have to, fish FIDO touch events to get them to do to authorize things. Within SSH, it acts just like any other key type. You can add them to authorize keys. You can stick them in an agent. You can forward them. You can authenticate with them. You can even use them as host keys if you sufficiently motivated, and you can have hardware-backed host keys that way. And to promote the use of these, we built these in OpenSSH, libSSH, and the Golang SSH library as well. Now we move from the stuff that we've done to the stuff that we haven't done, the stuff that we're optimistically yet to do, and that is generalizing Git's signing interface. Git's cryptography code is, I'd say, organically built around the expectation of talking to GPG, and those assumptions run fairly deep. Last year there was an internship at the Linux Foundation that started to pull these apart and really abstract the signing and verification and all the some of the identity code from being just GPG centric to being actually pluggable. So I think the motivating case was a crypto system called Hyperledger, but the work was going to be just as usable by us or by anyone else who needed to build a new signing interface into Git. Unfortunately, that internship finished without getting that work getting upstreamed. But I think even if you're not interested in SSH signatures in Git, I think this is important work because it facilitates the experimentation and also cleaning up the interfaces within Git for other cryptography. I think the next step here would be to make a decision of either to dust off those incomplete work, and tidy it up and get it committed, or to re-implement it if that's not possible or desirable. Actually getting Git to use these use SSH as a signer would be the next step after that.
Yeah, actually, before you go on, could you quickly go back and talk about the incomplete stuff? I realize I'm asking you. Can you give me an idea of scale of this? I mean, is this a hey, shouldn't take more than a couple of weeks, more than a couple of years, more than a couple of centuries?
I would say it would take maybe, depending on how familiar the developer is with Git, 1 to 3 months would be my estimation. I think someone who's very familiar with Git could probably re-implement it very quickly. Someone who's coming into Git, that would be my estimate. And I'm not super familiar with Git myself, like the internals anyway.
Yeah, is the hard part finding that person or finding the funding?
I think. Look, I think any competent C developer could do this. So I don't think it comes down to a person, but the right person means less funding, and someone who's got to come into it without that prior knowledge would have a longer ramp up time, of course.
And the Git maintainers, the Git code base and everything, they're happy to have this. It all makes sense. That's not an obstacle.
from my understanding, and I was at the end of a game of telephone here. Yes, Gavin, I believe that the work didn't land because they ran out of time. Yeah. Sorry, Dan, I got distracted. What was your question again?
It was basically the same, I guess, as Gavin's. There wasn't pushback from the maintainers or anything like that. It's really just a matter of getting the work done.
No, look, with caveats, I think they were fine with it. I think, from my conversations with some of the Git maintainers who work at Google, they are very receptive to any sort of patches that improve their internals, subject to the caveats that they're thoroughly tested, etc., etc. Which, good stewardship stuff. There was no in principle pushback to this. I'll move on. As far as getting SSH to actually use this, writing that glue is quite trivial. We've designed the SSH signature support around the needs of what we expect Git to use. It supports the operations, including some of the more esoteric ones, like checking a signature validates without actually tying it back to a user principal, which is an operation that Git does at some points. So we've done our best to anticipate the needs of a pluggable interface within SSH. So getting that basic glue between SSH and Git is quite simple. There is a wider story of actually making it usable within the context of repositories, and that's really tying up the identity loop of an identity. Who's the identities that's signing the key, matching that to an identity in the repository of a trusted pusher, propagating that throughout, propagating that relationship. I mean, as I mentioned previously, Git servers already have SSH keys for user accounts, be they system accounts or user accounts in the sense of GitHub, for example. So that information already exists at some level. It's just tying that all up and making it usable is the part there. There are some questions about how the coexistence of signatures. If someone signs a commit with both GPG and SSH, then that seemed to be okay when we were looking at it. That they're just both text strings attached to the object that was being signed, and it seemed that Git would deal with that. But we have to be sure, because we do need these things to coexist. There are active use cases that depend on GPG signatures that we must not disrupt, but we also want to enable new stuff, so they have to coexist.
Quick additional question: is there any objection to including the the public keys within the repo itself, so that anybody later can verify, who signed which?
Yeah, I don't think there's any. I mean, other than potentially developer privacy, I don't think there's any security reason why you wouldn't do that. I believe that GitHub, for example, allows you to query the SSH key of any user identity on the system, regardless of authentication. So that seems to be a decision that they've made that's not the case, and I don't see a problem with that. I think it's I think to actually to achieve this end-to-end attribution, you really need to be able to do that.
So you're just suggesting some schema or mapping of like GitHub accounts or email addresses to SSH keys stored somewhere in the Git repo itself, David?
I'm sorry, I didn't hear your question. I didn't understand your question. Repeat.
So when you said storing the public keys in the Git repo itself, you're talking about some kind of mapping of GitHub usernames or email addresses to public keys stored in the repo itself?
That's right. This key corresponds to this email address or whatever your identity is.
Yeah,
and then those would be like allowed pushers or allowed committers in that repository or something.
I think I don't think necessarily it's for security access. I'm thinking more in terms of being able to verify later on. The Linux kernel developers, for example, generally don't use they don't use GitHub, they don't use GitLab, they're using email. And then the question is, how do you verify later? Well, if it's in the repo, then there's no problem finding out which keys apply to which people.
Yeah, from my perspective, all it is required is that mapping exists somewhere, and that could be within the repo, that could be outside the repo. The SSH signature format embeds the entire public key within each signature, so they are to, you know, if that mapping doesn't explicitly exist within a repository, you still see the purported identity and the key that was used to sign, but there's no trusted repository host saying yes, they are one together. But you could, for example, attempt to extract that in retrospect. And the final piece, I think, is a wider discussion around cryptography in Git. I think I've mentioned that the approach to cryptography in Git seems fairly organic. Around it seems like the operations that exist have been structured around particular needs at particular points in time. Like we need to be able to sign a tag, we need to be able to sign a commit. But I've mentioned before some of these, mutating operations that will destroy signatures and verifiability of signatures, and coming up with patterns and workflows that preserve that attribution across these operations. For example, preserving somehow the original chain of commits, putting that in a place where people can get to it, countersigning with the person's key or the repository key when those commits are squashed, rebased, rewritten in some sense. And then, being able to have all that information available so that when you do want to go back and trace things back to their original source, that's all ready to go. Now doing this, I think, is probably going to be less coding and more documentation of workflows. There'll be a little bit of, I think there'll be a bit of code there to support, the countersigning and preservation of commit chains. But really having workflows that support this and maintain the attribution is really important as well. And that would look very different, for example, for a self-hosted repository or something like the Linux kernel to a GitLab or a GitHub or a Bitbucket. I think in the case where you've got a sort of active repository host, like one of the commercial ones, they can have their own resident keys that do all these countersigning operations, and it's a lot easier than in many senses than individual repositories. And there's Git supports multiple signatures types. There's push signatures as well as commit signatures, and push signatures are very interesting and attest to different things than signing commits, and in some ways are more useful, but they're not very widely used and not well surfaced in UI at the moment. So I think there's a discussion to have around that as well. So coming back to the vision, I think this is this is an important linkage in the total trust chain for open source software. If you can trust and attribute the source code, then a lot of other stuff becomes possible down the stream, and really tying this up as tightly as possible, enables a heap of other good stuff that follows. I think SSH keys are the most plausible and easy path forward for the reasons I outlined of them already being deeply embedded in the ecosystem, and I think we've got most of the pieces ready to go. And the next steps are relatively clear and straightforward to implement. I say with only a trace of hubris, and that's really it. I'm of course happy to answer more questions if you have them. Actually, I'll stay there in case you want me to go back to anything.
I don't really have any questions. Thanks for the explanation. I'd like to figure out what it would take to dust that off and get it going again.
Yeah, I've not looked. I've been kind of busy with other stuff for the last pandemic.
Right.
So, but I don't think the crypto code in Git has changed too much in the 9 months since someone was looking at it. And I the one of the things that was done as part of that work was a set of unit tests that I think fleshed out Git's testing, and I think that part of the work is important and can certainly be reused.
I haven't been as directly involved in the development of Git recently, but if I recall correctly, there are some changes in the crypto recently because they're trying to move away from requiring exclusivity on their variant of SHA-1. They've got a shim in there, so it's not actually SHA-1. It's a SHA-1 that's tweaked, but there's ongoing work to move beyond SHA-1, and that might impact that. I don't know what you're talking about.
Yeah, so the latest release of Git does support repositories that use SHA-256 signature, SHA-256 hashes as the identifier for objects. That is quite, as far as I can tell, orthogonal to the signing and verification. I think in both cases, the signing and verification code doesn't care what it's signing; it's just a bunch of bytes. So that shouldn't, that's certainly an important improvement with the SHA-1 being on its way out cryptographically from a security or from a safety perspective, but it's kind of orthogonal.
Do you know how involved the mentor was? I noticed you mentioned somebody's name. It looked like he's at the Linux Foundation. Maybe we could see if he's willing to continue mentoring, if we can find someone else.
There was some talk early this year about getting someone else, but then pandemic. So I don't know what happened with that. And again, I kind of was at the end of a game of telephone with one of my staff who was mostly doing this work.
If you could help track that down, David. You're muted right now. Maybe you're saying the same thing.
Yeah, I was just saying. It seems to me that we can at least shoot an email. I don't know either of these people. I know how to type an email.
Cool.
If somebody actually knows any of these individuals, that would probably be best. Does anyone know either individual? I don't have the names in front of me now. Can you wrap us back to those?
Yeah, look, I can when Kim shares the slides, I can actually put the David Hughesby's email in the notes.
Or just send it, Damien, if you don't want to put an email address on the slides without permission. Just send it to me, and I can.
Yeah, I'll have to actually dig the email out of my email.
I have the great power of pushing a compose button and sending an email. So so if you give me emails, I will be glad to send one, and I'll CC Dan and Kim if you like, or if you guys want to send it, that's fine too. But it does seem like at least asking the question seems like it seems like a reasonable next step.
Yeah, and look, I think that's one that is absolutely worth pursuing, regardless of whether you believe that SSH is the right solution for Git, because I think it would unlock, other the possibility of other experiments.
Damien, have you or is anyone else thinking about or straw manning what key management for this might look like more generally? Because that seems like I'm just sort of imagining all of this existing, and that seems like the next hard problem.
Yeah, the identity management, it really depends on the repository host. I think, and it would look very different for a commercially hosted repository like GitHub, GitLab, etc., than the Linux kernel or the hinky little one I keep on my computer at home. For a simple repository, they would probably use the SSH allowed signers format very directly, which is just it can be literally as simple as username key. That's it basically. It looks a lot like an authorized keys file. Something which is Git tiles or something like that could build it into its UI, and the commercial repository hosts have got whole teams that could build UI that I could only dream of. I think that it's really a UI question of how to surface it, how to make it comprehensible for users.
You probably want some standardization around that, though, wouldn't you? Because you need to be able to verify the commits later on. So, because like with SSH keys, often they're used to authenticate currently, right? Like with the authorized keys file, it's used to authenticate like on an ongoing basis the establishment of a connection. But if you're verifying signatures, you would also need historical key bindings, right?
Yeah, well, I think by virtue of the SSH signature format including the key as part of the signature, if you trust if you're checking out a repository from another from somewhere else, and you trust that repository to have verified that in the past, then you can just look at the identity of the commit and the identity of the key that signed it, and infer that mapping automatically, I believe. But
which is why I also asked about why not be able to store this within a repo, because for folks like the Linux kernel, they can review and say, yes, that key is acceptable, or no, that key is not acceptable, bring it in, and then in the future anyone can check those keys, even the historical keys.
Yes, yeah, and that's absolutely possible. Like the SSH, like the format that we implemented in OpenSSH is literally just a flat text file, and you could, if you don't like that format, it's trivial to generate from a format that you do like.
Is there anything in terms of expiration or limited time values, so that what basically what's the story along limited time, expiration of keys, revoking keys if you can do it,
Yeah,
all that glorious stuff?
Yeah, I think we build an ability to revoke keys into the format. If not, that's trivial to add. As far as key life cycle for bare keys, it's up to whoever maintains the list of trusted keys in the repository. But the system does completely support certificates, which do have built-in life cycles and a bunch of other features that are somewhat relevant, and they're pretty widely used, at least across some of the tech companies. I think Google uses certificates. I think Facebook, Uber, Lyft, they all use it. As far like those are the ones that I know of, and those that has the sort of dual benefits of providing explicit life cycle limitations, and also providing a reference to a third party trust root that is the organizational CA key. Exactly how that would unfold within Git is probably going to how to instantiate that in a Git repository that is then shared with other users is complicated, and there are some complications about being able to go back and verify a commit that was made in the past with a key that is no longer valid, and being able to discern that from a commit that was made right now with a key that's no longer valid but simply just lied about the date that it was committed. And that's a well understood problem in all signing systems that usually people solve by referring to some third-party timestamping service, which in this case would probably be the repository host.
Damien, I put my email address in there, so you know, I obviously I have no grand superpowers, but let's see what we can do to at least find out some information, and hopefully maybe make some progress.
Yes.
Yeah, and if
Yeah,
somebody can find a C developer and everything, I'm sure we can find funding for it if somebody is interested in this.
Well, although Get, I guess, isn't trivial. I've fiddled with the code briefly myself, and it is not a big program, really. It's it is not the Linux kernel.
I think David just volunteered.
No. Let me make that clear. I did not volunteer.
I was going to
I
say I take
volunteered
back
to
the
send an
funding
email.
promise if it's David.
Need a pandemic hobby, right?
Your microphone.
I like hobbies, but I already have a list.
Cool. Any other questions for Damien? Yeah.
Whoops.
Thank you, Damien, for coming.
Yes, thank you. This is very interesting.
Thank you all for your time. And I'll get the slides to Kim with, and feel free to email me if you've got any more questions.
Cool.
Okay. Do we have your email address?
It'll be in the slides.
Awesome. Okay.
Yeah, if we want to talk about this again, Damien, too, we can schedule more ad hoc times.
Yeah,
or
I think once some of the US comes off summertime, it gets a bit easier.
Yeah.
Next week.
Yeah.
Yep.
Good luck doing anything next week. But yes. Cool. Any other topics people want to bring up quick, or else we'll close out early today?
Was there anything this work group needed to close out before the town hall on the 9th? Was there?
Probably. I put time on Dan's calendar this week to hash some stuff out.
We're supposed to do like a 5 or 10 minute intro, but I haven't looked at that at all.
I mean,
Thanks for the reminder, Gavin.
Yeah. So basically, they just want something to say. 10 minutes, 3-ish slides. Really, it's the time boundary. It's whatever you can say in about 10 minutes. So I think for this group, it's very much here's some of the conversations we've had, and some of the we're basically gathering data, and here's some of the things we've learned, and topics discussed, things we've learned. You've got enough for 10 minutes.
I'll open an issue now where we can track stuff we want to put in there on the GitHub repo and crowdsource it.
Cool.
Any other ideas for what to put in there? Did you have anything in mind, Gavin?
I didn't know if there was top-down requests, for. I mean, obviously there's the name change if they were looking for, closed scope documents or anything like that. But it sounds like not.
Yeah, it's just it's really, I think the town hall is basically, its real goal is sharing enough so that people have a clue of what's going on and trying to encourage people to join. What I would do is I would start with the developer, the digital ID working group notes, and just try to pull out some of the, here's who you talk to, here's some of the key points.
Yeah, that sounds easy enough.
All right. Well, thanks everybody, and good luck staying safe and sane for the next couple of weeks.
Good plan. Thank you so much.
Good luck to us all.
Bye.
Bye.
Thank you. Bye.